This is the Amp Hour Podcast. Released December 23rd, 2018. Episode 421. The Legend of Kezyermas.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And this is Jeff Kaiser, a.k.a. Mighty Ohm.
It's
Yes,
Kezyermas. Kezyermas.
Kezyermas.
I knew you'd say it. I didn't even bother chiming in.
Welcome back, Jeff. How you been?
Thank you. I'm great. Thanks for having me back. Again.
This is like one of my favorite holiday traditions around the Amp Hour.
Well,
the more things change, the more they stay the same.
How many times have we done this?
Kezyermas, I think, is 3 times, and then obviously we had many, many more. So if people are interested,
Yep.
Jeff has his own category tag on the amphour.com. So you can just go and just listen to Mighty Ohm appearances.
That's how I'll bookmark it.
He was
on my...
a de facto co-host.
That's right, yeah.
At one point.
Right.
I was sort of a default substitute.
Default substitute, but also you joined us a lot too, so yeah.
Yeah.
Then you went and got a job. What are you doing, man?
I got a job and another job, and we've been doing this for a few years now. It's been it's good, but it's good to be back. Thanks for having me back.
It's good to talk to you, man. So what have you been up to? I remember. What did we talk about last year? Last year you were working on cars, or you were doing other stuff?
Last year I quit my job, and I was taking some time off to sort of
find yourself.
Do my own thing for a bit.
Be an artist. The artist formerly known as Mighty Ohm. Is that what we're doing?
That's right. Yeah, it was. I guess I was sort of on like a sabbatical of sorts. But yeah, I'd taken some time off and had gone back and was working on kits and working on a bunch of personal projects, and that's kind of how I wrapped up 2017. And let's see, over the past year, I'm working again. I spent the first half of the year sort of trying to figure out what I was going to do next. And then about midway through the year, I got approached by somebody that I'd worked with on a bunch of projects at Valve, and started doing some contract work. And that as things happen, that small project that started out just kind of a few hours a week has turned into a big project. And I've been now working as a contractor at Valve since May. And I got to tell you, it's interesting to kind of be in that position where, previously being a full-time and then coming back as a contractor, it's been interesting to go back. But working on some really interesting projects that obviously I can't talk about.
Well, that's it. All right, good show, folks.
Yeah, it was. Yeah, thanks for having me. Talk to you next year.
There's definitely electronics, and we definitely can't talk about them. So whatever.
Do people treat you differently now that you've come back as a contractor?
I'd say yes and no. I think that everyone's different, and I have to say that a lot of the folks that I've worked with for years and years, things are just sort of back the way that they always were, and it's really, there isn't really much of a shift. I'd say that, as a contractor, I don't get all the same benefits, and obviously I've got to keep track of time and do all the things that are around billing and all that stuff. So there's some overhead now that I didn't have before. And that's something that I've done previously, because I've done freelance work before in years past, and I had all that set up. So that wasn't that big of a challenge. But that is sort of this overhead that, as a contractor, you need to consider. And then there's also sort of the mechanics of money, I think, are one of the places where there's the most friction around being a contractor, because when you're a full-time employee, if you're lucky enough, you have a corporate card.
Everything's
and
already
you
paid
get
for.
To well, it's not. It's actually not so much that. It's like the business expenses. So the processes of creating POs and placing orders and having a company credit card that you can charge travel to or charge expenses to. I think that I sort of well, I won't say that I took it for granted, because I was always felt very fortunate to have a company card that I could charge expenses to. But that's probably one of the things well, I'll say it's one of the things that I miss the most. Because getting reimbursed for expenses and things like that's a lot longer process. And as a contractor, I remember when I first started out, one of my first freelance jobs that I had when I first started contracting. This is now 10 years ago when I first started this. I remember having to float the cost of an SMT build, and I basically spent every dollar that I owned. Like I emptied my bank account in order to float the cost.
Cash?
When I started contracting, I did not have a credit card. That's how much of a newbie I was at that whole thing.
Okay.
And so I had my debit card, and I was, this is quite a long time ago. So I was paying things with a debit card. Do not recommend that. Don't do it. If you're contracting, don't even go there. But I was actually paying out of pocket for component and PCB assembly costs, and I remember going through a couple tough months where the bank balance was like heading negative, and that can be hard. And so going through kind of back in that business again, and having learned a lot from having done this before, it really just means that there's some overhead that's associated with spending money, and I think that's something that as a full-timer I did take for granted. It was a lot easier to do that, and as a contractor, you sort of have to get approvals, and especially at a company like Valve that's a pretty flat organization, for the full-times, there's not a lot of overhead to doing things like that. And that's one of the greatest things about Valve, is that they empower the individual engineers to be able to spend money and spin up projects and do all those things fairly independently and experiment and do all that great stuff. And I think as a contractor, I'm used to that because that's kind of where I came from. But now I've got to sort of think more explicitly about how to sort of drive that process. And that's something that is definitely a change.
Yeah. Well, that's good, man.
How does contracting work in the US? I know it probably varies, but do you do it through an agency, or do you invoice them through your own company or whatnot?
I've got my own company, and I'd say that I'm probably in the minority of folks.
I was going to ask, yeah, right. So most would go through an agency, would they?
Yeah, most folks do go through an agency because, the agency helps you find work, deals with a lot of the overhead, in some cases may provide health insurance, things like that. There's a lot of benefits to working through a larger agency.
Even in our field, even in our professional engineering field, people still go through agencies?
Yes, absolutely.
Mostly, you think?
At least in this area, in the Seattle area, it is very common. And actually, some companies will only work with agencies.
I was going to say. I heard about that. So I was talking to a big consulting, a small firm that got bought by a much bigger firm, and they said, because of the change, basically, this bigger firm that they got bought by will only deal with big company with a contracting house that basically has a stable of contractors. Because you think about having a roster of, now you have, instead of say 100 contractors that would all have their own LLCs or businesses or whatever.
Oh yeah, that'd be annoying.
They would basically have one they deal with, and then because setting up each new vendor is like a huge deal for a big company.
Yeah, that's exactly right. And I think that is the biggest reason that most large companies will very reluctantly, if you're like an expert in your field, if you're
Jeff Kaiser, I mean, come on.
They'll do it for you.
If you were the Mighty Ohm, I mean,
say that if you're the Henry Ott, you're the EMC expert, or you're the resident expert, then things are a little different. You're consulting at that point, right? That's kind of a different engagement. But I think contract engineering, you're absolutely right. It's mostly larger firms that are doing that, and I think there's advantages and disadvantages. Obviously, there's trade-offs. So I'm direct.
I've noticed you have not joined my consulting forum yet, though, Jeff. I mean, I'm a little miffed, I got to say.
So how does this work? If it's like here, when I was contracting through an agency, you basically didn't know, they charged the company extra, so you really didn't know what their cut was. it's like you negotiate a salary, like you would negotiate a salary with a contracting rate with the company. It might be $50 an hour or something, and then the agency would charge them $50 an hour plus whatever their
60 total an hour or whatever it is, right?
I think that's very common, and I think that every agency is going to handle that a little bit differently. I've worked with a lot of contractors over the years, and I've seen the whole range. I've worked with contractors that knew exactly what the breakdown was. I've worked with very small agencies that are very transparent about how that works, and I've also worked with big companies it was hard to even know. Even as the guy who was approving those expenses on the company's side, working with the contractors,
right.
I had no visibility into what the individuals were being paid. So I just knew what I was paying the contract company, but I didn't know how that was trickling down to the individuals.
Interesting.
So I think there's a whole range. Some agencies are not very transparent, and to be honest, sometimes it matters, sometimes it doesn't. It really depends on the situation, and it depends on who you're working with. And I mean, I think there's an expectation that by working with an agency, they sort of take care of a lot of that, so that
and they're finding the next job too, right? I mean, that's the other thing.
Yeah, exactly. So there are a lot of there's a lot of advantages, but I've also worked with agencies that were quite transparent about it, and I think it's just sort of it's going to vary.
Well, you can't talk about the projects you're working on, but where do you see what's your state of technology, Jeff? What's 2018 been like for you? Are you excited about FPGAs? Are you excited about micros? Are you excited about RF? What do you what's you into these days?
I'm excited about signal integrity.
Oh,
that's an area that
Oh, that's it. Valve, make the announcement now. Valve are coming out with a new signal integrity product.
Yeah,
there you go.
Yeah. They're making a
clearly
VNA product. It's great.
Well, so it's
game,
kind of interesting.
It's a game that you play that where you find the dispatch traces.
The name of the game is going to be the signal. You're going to fly down the transmission.
If that's not a game, it needs to be a game, because I think looking at reflections and discontinuities and moving transmission lines around. I mean that's kind of what that field is about. And
you could have a character just named Stub. He
could be like the Clippy,
exactly.
Character. He's your
sidekick. Yeah.
The
your sidekick.
Terminator.
Yeah.
The Terminator. Yes.
Gosh, we've got to get on this, guys. If only someone knew someone at a game studio.
Yeah, right.
I mean,
right.
geez.
Oh, well.
Right. I mean, you should call Zachtronics, man. That would be, if anyone would do it, it would be Zach from Zachtronics.
That's terrific.
Former guest of the Amp Hour, if people don't know. Highly recommend his games.
Yep.
So signal integrity.
Okay.
I think that's been a lot of my focus for the past few months, and it's an area that I think I've always been interested in.
Yeah.
Being an RF guy, you kind of you're nearby, like it's a similar area. People tend to specialize in one or the other.
You're talking about impedance either way, right?
You are, you're talking about impedance, but like there's some differences. Like,
well, just because you're an RF guy doesn't mean you instantly know all there is to know about transmission lines and termination and like as on the PCB and the digital, threshold level and stuff like that.
I think that is it's. I agree and disagree with that. So I think that all of the transmission line stuff that as an RF designer you're exposed to in your career, that's all super, super relevant. And I think that
absolutely.
If you're talking about like microstrip lines and transmission lines on boards, strip line and stuff like that, that stuff is the bread and butter of high-speed digital designers. And I think that that used to be the territory of RF guys. Like if you looked at that like 20 plus years ago, that was what the RF guys were doing.
Well, if you're doing it wrong, usually you're emitting RF, right? I mean, like there's that part.
No, these are connected.
Right.
But as high speed digital has become more common, I think that it's made everybody that's in digital have to become more of an expert in transmission lines and high speed signal propagation. And so I think that's an area where when I was first starting my career in RF, people were talking about that and saying, well, analog RF is going away. It's going to be replaced by, everything's going to be digital. Even radios, they're going to be totally digital. They're not going to have any analog.
They weren't wrong.
And so the writing was kind of on the wall at that time that digital was going to have a big role in, well, yeah.
I mean, yes, there's still analog components, but come on, it's a lot of.
It's becoming increasingly digital. We've got software-defined radios now. We have all this stuff. But when you get bits onto a printed circuit board, there are electromagnetic effects that are the same as for RF systems. And so there's a lot of commonality there. I will say that some of the lingo and some of the concepts are quite different, though. So we've got transmission lines which come from the RF side and are now being applied to digital systems. But the concept of jitter, that's something that you don't hear RF guys talking about. At least RF guys that are on the analog side don't talk about jitter and the concept of jitter. And that's one of the core metrics of channel performance for signal integrity is how much jitter is there in your signal. And it's that area that for me is, I've been exposed to it in the past, but I would not call myself an expert. But I'm my job is requiring me to become more knowledgeable in that area. And I think that's been, for me, one of the most interesting things to explore in 2018 has been that side of signal integrity, and then also leveraging the transmission line and termination and impedance matching and all that stuff.
So what do your tools look like then? Is this those eye diagrams that you see on really fancy scopes and stuff
Yeah, that's right.
Okay.
Yep, that's right. So you've got eye diagrams are one of the tools to measure signal integrity, and so some of the tools are the same as RF. So a vector network analyzer is a tool that is very useful in signal integrity. You'll use it in frequency domain, but you'll also use it for time domain measurements. Usually on the RF side, you don't care about time domain or care about it as much. But in the SI world, time domain response is much more important because you have edges that are bouncing around and you're looking at impedance discontinuities down the transmission line. And I won't say that TDR isn't useful in the RF space. I think I probably, if I were to go back to RF,
TDR?
I'd use it.
Sorry, Jeff.
It's time domain reflectometry, which is basically so you can measure time domain in two ways. You can use a frequency domain instrument like a vector network analyzer, which basically looks at reflections and transmissions of signals versus frequency, and you can actually do a Z transform to convert that to time domain.
You hear that, students?
So you can basically,
there is a reason. There's a reason you learned it. You don't need to actually know it probably as much, but
hey kids, pay attention in school.
Yeah, that's right.
It's all really
Signals
important.
Classes are very important.
Yeah, exactly. That signals stuff that you're probably not paying as much attention as you should. You should really pay attention because it is important. So that's one way you convert frequency domain data to time domain, and that's that whole Laplace transform, blah 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 stuff, or Fourier transform,
blah blah blah,
converting frequency domain to time domain, and vice versa. The other way you can do it is you can actually generate a very fast edge, and then you can actually launch that edge into your circuit and look at what comes back. And that's more of just pure time domain. And there are purpose-built TDRs that do that. But
I always think about that as you're like one of those demos at a science museum where you have a wave table, and then you have the first wave goes down, and then it bounces back, and you see how the interference pattern happens, and you see what it looks like, and those are cool.
Yeah, or like a wave going down a string. And then if it hits if it hits the other end, it reflects back, and that's transmission lines are like that. And there's a lot of great books on this stuff. I think Bogatine is one. Howard Johnson, what's the Black Magic? The Black Magic book.
It's Eric Bogatine.
Sorry,
there's two parts to that too.
Yep. Which one? The Howard Johnson
sequel to that. Yeah.
Okay. Keep going, Jeff.
Oh, sorry. Yeah, so there's a lot of good literature
on Henry Ott. I'm sure you would probably list that in there, right?
That Henry Ott's EMC compliance book is one of my favorites. I think that's something that it's maybe a little bit less signal integrity oriented, but one of the other areas that I work in and I still work in is EMC and regulatory compliance. And I think that for folks that consider EMC to be sort of black magic, that book will demystify a lot of it, and it's one of the books that I recommend to a lot of folks that are new to compliance, and especially understanding why products have issues with compliance and then how to fix them. I think that book sort of breaks it down. And I think the title of the book is Introduction to Compliance Engineering. I'd have to check. But it's Ott's latest book.
I would also mention,
by the way,
I would also mention that both Eric and Henry have been on the show. We did not get Dr. Johnson. Wait, did we get? No, we didn't get him. No, he retired first. So we didn't get him.
I think Henry Ott just retired, actually.
Oh, yeah?
I took one of his classes about 3 or 4 years ago, and I think I'm on a mailing list, and I think I heard that he just retired this year.
There you go.
Wait, we did interview Dr. Howard Johnson. Jesus.
Yes.
Holy crap. We've done a lot of shows, Dave. I've literally forgot. No, I do remember that because he asked us to introduce him. That's what it was.
That's right. Yeah. I remember.
He's the only guest we've technically introduced other than Jeff, just today.
Yes, that's right.
Oh, sorry. The book is Electromagnetic Compatibility Engineering.
Yeah.
Really, really good book. It's kind of, it's not a thin book, but it's totally, it's great. I highly recommend that one.
I thought we didn't interview Dr. Johnson.
People often complain about the cost of these books, but seriously, the knowledge contained in them is worth its weight in gold.
Right. Well, you could hire Jeff for
just
half an hour for the same cost. Pretty much that's what it would you would get, and maybe less time.
Even if a textbook costs a couple of $100, that is cheap learning material.
I think it's natural for people to rail against the publishing companies, but at the end of the day, just swallow your pride and pay it. It's probably or get it at the library if you can. Like university library lending and stuff like that.
But, you can always borrow it from the local uni library. Sure.
Well, that's cool, man. It sounds like you're doing some interesting work, though, Jeff.
Yeah, it's exciting. I mean, for me, it's a way to kind of get my hands dirty and work on circuits and work on boards, and I like getting into the lab, and it's been great to be back and work on some interesting new problems in an area that is new to me. Like when I worked at Intel back when I was in university, and I remember folks there who were probably much younger than I am now talking about signal integrity and talking about, at that time, RAM bus was sort of the big thing. I remember RAM bus.
I remember my first computer had RD RAM, and it was really expensive to ever upgrade, so I never did.
And so I remember them struggling and using some of the same types of tools and techniques that I use now. And so it's interesting to kind of have that come back around, and now I'm the guy who's talking about all the same stuff that they were back then.
Yeah. What about
when you took your 6 months off, or was it 6 months?
It was almost a year.
Sabbatical,
almost a year.
Yeah. How did Mrs. Mighty Ohm? Because obviously, you had little, honey, I'm just going to work on, I'm just going to bum around in the lab and work on some kits and stuff.
Enjoy your day of work, honey.
For the next year. Was she okay with that, or was it a...
She was very supportive of it, and I think that
I will say I've met both Mrs. Mighty Ohm and Mrs. E. Vubog, and both are very, very awesome human beings. So
she was very, very supportive, and I think that for her it was important. So I think first of all, we have to take a step back and say that in that time, it wasn't like I was kicking back on the couch watching TV. I think that my idea of not working full time is very different, because really I'm working full time. It's just I'm doing different stuff, and I would say that I was pushing myself just as hard and working as many hours a week, except when I work for myself,
there's no money coming in, right?
Well, that's not totally true. So one of the biggest things that happened to me in my non-Valve life this year was that Elector, the European electronics magazine, started carrying Mighty Ohm kits, and
there you go.
That by itself was a big part of 2018 for me, because it had been kind of a long time since I'd brought on a new distributor. And, as happens, you sort of go into it with an idea about, okay, maybe this is going to be a few kits here or there, whatever. And then pretty soon you're spending every waking hour building kits.
Right.
And so
Yep.
that was sort of a big thing that happened in the middle of the year for me that was totally unexpected and was really great, but also was definitely a big time commitment for me. I spent a good portion of the year sort of ramping up because, honestly, I've had the Geiger counter kits have been out for a few years now, and things were slowing down a little bit. I still was getting orders, but it was sort of slowing down. And then all of a sudden I found I was having to order, larger quantities and sort of ramp things back up again and sort of dust off. It wasn't like it was dusty, but it was like I was building at a certain rate, and then I needed to sort of turn that around and start building at a much higher rate. And it's super exciting, but it's also one of those things where when things go really well and you're working with a distributor, they kind of, if sales are going well, they go from 0 to 100% really fast.
Yeah.
And I think it's hard as a small business to respond to that. And, as a small business, you don't want to overestimate what the demand is going to be. If you're building something like a kit and you get an order, it's tempting to say, well, if this continues at this rate, I'm going to need to order X more, and I should just, there's a lot of economy of scale, and it's easy to kind of get lost in the, well, if I buy 10,000 of this resistor, it's like a penny, it's like 10 times cheaper than if I buy 100. And so managing that is hard. And as a small business, I'm just a one-man operation. I don't have employees. I farm out some of the components, but I do a lot of it myself. So there's sort of a limit to what I can do in a given week. And I went from that being a very small portion of my time to, at least for a while, that being a very big portion of my time. And that was exciting, but it was something that I was, kind of unprepared for, and that caught me by surprise this year. But I can say that I'm finally sort of on top of that, and it's been great. So if you go to Elector's website, you'll see the Mighty Ohm Geiger counter on there.
Nice.
Excellent.
Nice.
Is there enough margin in there to make it worthwhile with the dealers and stuff like that? Especially a large one like that?
I'm pretty happy with it. It's not a lot of money. I think that the distributors do take a cut. But for me, it's been enough to make me want to keep doing it. I will say that now that I've got a day job that sort of pays me by the hour, it makes me much more aware that if I have to miss a day that I could come to my sort of full-time job in order to deal with the kits and to do kits, that's not a great trade-off. And that's something that I think is a big difference as a contractor versus a full-time. Because when I was a full-time employee, my income was not really proportional to the amount of hours per week. And I'll say, first of all, I'm the kind of guy that I work more than 40 hours a week. That's just sort of that I've always done that. And so I'm usually working more than sort of the minimum. But if I spend a few hours here or there doing kits, it
37
was sort of
pieces of flare. That's how many he wears, folks.
Yeah, you don't want to work the minimum number of
Jessica,
hours.
you don't want to. 15.
And I'll say that Valve is a great company to work for, and they're not like pushing you to put in more hours. This is entirely self-driven, wanting to do great things and be successful. But I'll say that as a contractor, if you're like, oh, well, so I need to ship whatever these kits this month, and I'm kind of running out of days, and so maybe I should just take some time off and deal with that. You quickly are like, oh, that's actually not a good trade-off. That cost me money,
thousands of dollars.
Right.
Yeah,
right. So that's a tough thing, but I mean, I'll say that I've found sort of a balance there. Things have slowed down a bit since the summer. The summer was a little bit nuts. Things have slowed down a bit, and I've been able to manage it. And honestly, the kit business is tremendously rewarding. That's really something that I enjoy doing because it's entirely of my own creation. I control the entire, not the supply chain, but I control a lot of the supply chain for those kits, and I get a lot of enjoyment out of it. And it also connects me with people sort of all around the world who buy something and they like it. And I think that's something that is a different kind of a reward than I get from sort of my day job. So I
concur. That's why I've been in the kit business for 20 plus years.
When I was a boy.
When I was a boy.
So
I can
great.
totally understand those that reward side of it. That's why I still do it too.
I'm not there yet, guys. I'm sorry.
No, you're not. Start a kit business. Come on.
Yeah. Well, Jeff, it sounds like you're doing good stuff, man. You're back in it. I mean, was it tough transitioning back into the electronics world? I mean, like you were kind of. I guess you weren't really out of it.
I am never not in the electronics world. I mean, I think that's one of the things. I have been working in electronics since I was in kindergarten. Like I've been able to solder since I was a little kid. And
were you a child laborer? I mean, what?
No, I mean I've been into hobby electronics my entire life since I could read.
Mm-hmm.
I was drawing schematics, and I think for me that is the one common thread. I spent quite a lot of time during my quote unquote sabbatical working on other things, and I have to say that I always come back to electronics. I think that that's the one thing that I don't know. I think that's sort of for me. That is what I was meant to do, and I think that I'm fortunate that I sort of have that calling, and it's an area. It's not like my calling is something obscure that would be challenging to find work in. It's there's a lot of opportunity for people in the electronics industry, and I think that right now hardware is big, and in the Seattle area, hardware is big. There's a lot of opportunities in Seattle for hardware, and there's a lot of really interesting places to work right now.
Yeah, you and I talked. So I got to visit Seattle back in June, and that was fun to hang out with you. And we were talking over lunch, and you guys were kind of mentioning like some of the where you knew other people in Seattle. So what is the Seattle scene like right now?
I think that it is growing. Seattle just has had a lot of sheer population growth over the past few years. Seattle has gotten a bit more crowded since I moved here in 2012.
And now you're like a NIMBY. You're like, yeah, darn kids, don't move here.
No, I think it's great. So Seattle historically, and I'm not a Seattle native. I've only lived here for 6 years now. But to my understanding, Seattle historically was rooted fairly heavily in the aerospace industry. Boeing is kind of the famous example. But also has had companies like Microsoft have been here for a long time, and Microsoft has been building hardware
for the airplane
here
as well. Yeah.
Aren't Tech near there?
Tektronix is in Oregon. That's Beaverton. Right. I actually drove by the Tektronix headquarters recently, and it's impressive. Tektronix, I don't think was ever.
Sorry.
I love Tektronix. I definitely wish them the best. I actually am fortunate to work with some former tech engineers, and they're all great engineers. And I'm sure that there's still a lot of engineers that are still at tech. But yeah, I mean, tech has been through a lot of changes in the past decade. And another company that's been through a lot of changes is Fluke. Fluke is based in Everett, and they've been there for, I think, quite a long time. And I don't actually know anyone at Fluke, but I'm sure that there's still interesting things happening up in Everett. It's actually interesting that Seattle, that Everett area, which is about half an hour north of Seattle, I think because of Boeing and because of some of the aerospace stuff that's been there a long time, there are other companies that are in that area that are in sort of the technology industry. But
well, it goes like one person works at a big technology place, then they make some money, or they decide to do their own thing, and then they open up shop down the street because they already live there, and just
I mean that's one of the great things about recessions, right? Is that when
Jeff Kaiser, honestly, all about recessions.
Honestly, I think that so using Seattle as an example, Seattle historically, you had Microsoft, we've had Amazon for quite a long time, you had Boeing, you had some other very established companies. I think, if you compare Seattle with, say, the Bay Area, I think Seattle, at least to my impression, is that it was far more concentrated in far fewer large companies, right? Seattle historically had relatively few companies. And, we have had some very significant recessions. Seattle has had a couple major downturns. Boeing, there's kind of a famous one, and I'm not sure the year, but it was 70s, I think. Boeing had a big downturn. And what happens is that people leave or people are let go, and then they go off and they create other companies.
Oh, yeah.
And honestly, that is a great process for technology, for an economy and an area in technology that kind of refactoring, and people move around and they do new things and they do interesting things. I mean, I think the Bay Area does that every time there's a recession. Folks leave or they get let go and they do something else and they create a new company and they do something new. Yeah. I think that's a great way of diversifying a tech industry, and Seattle is on, its second or third or fourth iteration of that. And I think that there's still relatively few big players in Seattle. Amazon is huge, and Amazon's doing hardware. Lab 126 is doing hardware and is connected to Amazon. They're in the Bay Area, but they've also got, I think Lab 126 has an office in Bellevue, which is close to Seattle. That's actually where I am right now. Microsoft is obviously still big in hardware. And there's Google's up here, but I don't think they're building hardware. It's primarily software. But you've got, there's a number of companies that are in this area. Facebook obviously is up here and is kind of a big force in both hardware and software. And I think Seattle's still sort of growing. I think there's a lot.
What is Facebook doing in hardware?
They bought Oculus, Dave.
What?
You remember Oculus? The Oculus Rift?
Oh,
they bought
right.
them for $2 billion. So now they're in hardware.
Okay, right.
I think Facebook was actually building hardware before that.
Oh, yeah.
And Facebook
they have that portal
has
now
been building servers.
That
stuff. I'm sure they're doing that sort of stuff, yeah.
I think at a company of sufficient size, they just it starts to actually make sense at a certain point, even if it's, weird stuff or it turns out to be a flop. I think.
Oh, when you're that huge, of course, it's it's a foregone conclusion that you're going to end up making your own stuff.
Mm-hmm. Yeah, it becomes like a vertical integration thing almost.
Yeah.
I went on the Boeing tour recently. Boeing has a great tour of where they build 747s, which, by the way, they're still building 747s.
I was going to say, I thought they shut that down.
They are still.
They actually
they are still making 747s. They're cargo planes.
Oh.
So they still build cargo planes. They also build 777s, 787s, 737s. And I'll say that going to that factory, you can get a tour, you get to see the assembly line. You sort of you have that moment of this is what vertical manufacturing is all about. But I will say that even Boeing, they're doing this program now where they assemble aircraft from components that are built all over the world. Like the wings will be built in one country and the tail is built in another country, and then they bring it all together. So I think even Boeing is a lot less vertically integrated than they used to be. But it's still, to go to that factory and to see that, it's a really impressive sight, to see the amount of machinery and all of the sub-assemblies that are built into aircraft. It's really amazing to see.
I don't care where the wing or the tail or anything is. I just care that the QA is really friggin' good.
I imagine that quite a lot of effort is put into that.
Quite a lot,
a small amount of effort
right.
is put into that.
That's good.
I am just looking. I've got to tell you this. I'm just looking at Google Maps. I'm just, to get my bearings. And I'm looking at Fluke headquarters. It's got a helipad.
Oh, my God. Seriously?
Fluke headquarters has a helipad.
Well, Dave, that's got to be a fluke.
Sorry, I just had to mention that.
It's for the Danaher folks to fly in,
Right, yeah, of course. Yeah. Makes sense, obviously.
So I was wondering, what do you guys think? I mean, we're running up on the end of the year here. What do you think about talking about a year in review as part of Kezyermas? I mean, what did we just things we've seen in this year's tech, things that we think will happen in next year's tech, stuff like that. Because right after the holidays,
God, don't spring this on us.
Well,
wait,
man.
Is this our chance to make wildly inaccurate predictions about the future?
Well, Jeff, that's our chance to do that every single time we record the Amp Hour. But yes, now that you're here, it's also your chance to do that.
Oh wow, yeah. It's my chance to embarrass myself with completely wrong predictions.
I've never been embarrassed. I just I believe these things in my heart, so they must be true to me in my heart.
Well, what things haven't happened? What things have gone the way of the...
do we have...
that was all the latest boom, and then they went, VR is all this augmented reality, virtual reality. It's meh,
Jeff's employer might think otherwise, but
Jeff's employer might be a bit. But no, but like everyone said, it was imminent and it's the future and everyone's going to be playing.
I think it's slower. It's definitely slower than that stuff, and like AR as well. I mean, that stuff has been.
3D printing just died in the arse, like it was going to be the next big thing.
I do not agree with that at all. I'm actually sitting, I can see from where I'm sitting here, a room that is completely full of 3D
automation,
printers.
Come on, the home automation, like the home thing, everyone was going to have a 3D printer in the home and it was going to, you wouldn't have to go down to the hardware store and buy a doorknob anymore. You just print it.
The dreams of Brie Pettis, that's what you're talking about, right? The prognostications of a less than...
That failed, Misra. That died in the arse completely.
I think that I think they were shooting for the moon and they got somewhere that was in low Earth orbit, and it's still really impressive. It just wasn't the moon.
I think it's gotten
commoditized.
I think it's deorbited. I think it's
gotten commoditized.
No way.
It's just not. Maybe that promise that you're talking about is my grandmother doesn't have a 3D printer, but.
Exactly. It just nobody does because it was
no, that's definitely not true.
There's still, come on.
I think that we take 3D printers for granted now. I think that I would challenge you to find a single consumer product that's designed today that doesn't make heavy use of 3D printing in the product development process. Yeah. I would wager that every
product development. I'm talking about Joe Average in their home. That's true. With little Joe Average,
printing
Joe
the
Average is not
mechabots or whatever
out
it is,
his toys with 3D printers.
I agree with that.
I think that there's a lot of 3D printers that are out there. To me, 3D printers are not rare. I mean, you're right, and that people that are not technologically minded are maybe not pursuing 3D printers.
You don't see them in like Best Buy as much as you did during that hype,
That's right.
the top of that hype thing. I agree with that.
That's true.
But Jeff, I agree with Jeff that I've 3D printed more things in the past 4 months of consulting than I had in the past 5 years of having a 3D printer. So it's just, I think some of it is focus.
I have no doubt. That's not the argument. Yeah.
Okay. Yep. Yeah. Sure.
For sure.
Do we have a list of predictions from last year that we can go and laugh at?
I don't know. Driverless cars,
self-driving cars. That one.
Self-driving cars.
Well, I'll say that every time I see a Tesla on the road, I feel like we're a little closer to that.
But then again, you get the likes of Steve Wozniak coming out and bashing the Tesla Roadster and the Tesla. He says he's got one, and he was so... waiting for the, like he thought it'd be so fantastic. And he goes, no, it's basically not what they promised. It just, it's kind of sort of neat toy, but it's not the driverless car that was promised.
I don't know. They can parallel park themselves.
That's the was. I think. Well, you could have parallel. They had parallel parking cars in the 40s.
That's true.
You mean when the wheels turn sideways and then they just pulled into the spot? Is that the thing? It's like some
That's right. I wouldn't have wanted to park in front or behind one of those self-driving cars in the 40s. I think that. I think that maybe the common thread we're seeing is that each of these have had an intense amount of hype involved, and then you sort of get to the plateau where. Yeah, they exist and they're increasingly a part of our lives, but it doesn't have that like upward trajectory anymore. I don't know. I think give it time. It's probably we're on a plateau, but then somebody's going to do something to elevate it again. And I suspect that there are quite a few engineers that are working on solving those problems.
Oh, for sure.
So I think we're going to see a lot more self-driving stuff, and we're going to see it work better. And whether 2019 is going to be the year where that becomes mainstream, I don't know. I feel like the auto industry moves a bit slowly.
I'm telling you it won't be. I guarantee you. No. Won't be. I'm hanging my balls out there on the chopping block, making a prediction.
Don't need
Come
to
on,
do
guys.
That. Oh, there we go. I was trying to find...
Just like that chip, just like the chip printer I put my head on the chopping block a decade ago.
A decade ago. It wasn't been a decade.
And we're halfway there to the 20 years, Chris. You do realise
We're not a decade, Dave. We've only recorded the show for 8 years.
What, 9 years?
8 years.
8 and a half? Come on, I'm rounding up.
Okay.
we're pretty much halfway there.
So I'm going back and I'm looking at the past episodes of. I'm just ignoring Dave like I normally do when that comes up.
Of course.
So we actually have. This is a tradition. This is actually number 5, I think. So 229, 279, 328, 365. Last year you had just gone on that tour of the thing. What's that?
The Hanford site.
Yeah, the Hanford site. Right.
Yeah.
Oh, that's right. Yeah.
And then the year before that, you had just seen
amazing.
Dave. And that was when we had the picture of you grabbing the Sydney Harbor Bridge bolts and nuts.
Nuts, yep.
Before that was you selling. I think you were talking about your working on the. That was when the video had just come out of the Steam controller, so we talked about that.
I think we missed a year though. There was the Idea Factory year.
No, that's in here too. That's.
Oh really?
Yeah, okay. That was the. No,
that was the year that I went to Bell Labs.
That was the Sydney. Yeah, so that was the Sydney one. We talked about that.
Oh, okay.
Yeah.
Okay.
Yep. Yeah. So I don't think we have any other predictions here. 2 years ago, we had the batterized will start shipping soon. Did that ever happen?
Yeah, they shipped.
Great. So
didn't work. Well, it worked, but it was exactly as we all predicted. Okay. Its performance sucked.
Yeah.
Yeah. Funny how engineering works like that, isn't it? How you can actually predict stuff.
Yep. Yeah, I don't know. So I think the coming year, I think the rise of the open source FPGA toolchain stuff is very, very exciting. I don't know about you guys if you've been watching that stuff, but I think that's a bigger and bigger deal, and I think that ties into like I think that's getting a lot of traction because of the slowing of Moore's law, slowing/stopping of Moore's law in the first place. That more people are actually interested in optimizing custom logic and things like that. Maybe not.
But with the advent of faster and faster, higher speed and cheaper processors, like where is the magic
balance point
market? You know, where's the killer app going to come for the FPGA evolution, so to speak? I mean, you know, this was Altium's dream.
Sure.
Right? Altium spent 10 years developing this, and it never happened. And I don't see it. I don't see anything that's changed.
Well, we might get a taste of this.
That changes that. Really.
I shipped 4 microphones and my H6N recorder to Peter Ezdentemsky to take to Chaos Communication Congress, and so we will have a foreign correspondent in the coming days, hopefully, and he's going to record with former guest Clifford and former guest Clifford Wolf and Tim Ansel, and they're going to talk about FPGA stuff in Germany. So we'll see. We may get a inside look at the forefront of that stuff. So I'm excited about it, though. Yeah. I don't know if you guys are... Jeff, are you doing any FPGA stuff, or is that not...
No, not no. I haven't. I've played a little bit with some of the dev kits that have come out over the years, and I know that the tiny FPGA is really big right now.
Yeah, Luke Valenti. Yep.
But yeah, I unfortunately haven't not had a chance to play with that stuff. I'd like to.
Yeah. I have a tiny FPGA in hand, and it's like the other pile of I've got dev kits that I keep saying like, oh well, Christmas time is the right time to pull that stuff out. I'm sure I'll
Yeah.
I've got that one. I've got the LoRa board. I've got the a couple other things. Got the PSOC 5. I've never actually done any PSOC stuff before, so I was going to try that one out.
Oh yeah, I have. They're cool. They do. Yeah, they're neat. They've got some interesting peripherals. That's one of those things that I feel like a lot of undergrads use that in their projects because they do that analog and digital in the same part kind of thing. Those are cool parts.
Well, Dave, come on, man. You're the prognosticator here. Tell us what isn't going to happen or is going to happen. You actually know. You're only allowed to say what is going to happen.
I'm the only one who's stuck my neck out and said this isn't going to happen.
No. You only are allowed to say things that are going to happen because you always love saying
that are going to happen.
You love saying things that are not going to happen, and that's fine.
Because it's obvious to see that. I mean, it's much harder to, predict what's going to be big. I don't know. You've sprung this on me.
All right. We can talk about something else then.
I don't see anything. Yeah. I don't know. Nothing comes to mind that's going to be the revolution in 2019.
I think that 2019 is going to be the year that USB Type-C becomes more common than micro USB, right? I think that's been in the works for a while, but it seems like things are moving that direction.
My new product, my new micro supply, we've decided only USB-C.
Oh, wow.
on.
Okay.
Mm-hmm.
Because it's just easier, because you can buy and you can ship with it a little USB-C to micro USB adapter if you want it.
Mm-hmm.
And that's actually just as cheap to include that little adapter than it is to put the micro USB on your board, really. I mean, it's, it's almost as cheap, but it gives the customer like an extra little doodad. Oh, look, I got a little adapter with it. Isn't that nice? Rather. So, the original concept was to have USB-C, actually all three, let's just satisfy everyone, and then in the end, we just went, oh, no, this is, it's getting a bit silly. Let's just go with USB-C, and if people want, we can supply an adapter with it, and Bob's your uncle. Mm-hmm. So, yeah.
So are you guys seeing that?
I totally agree with
I haven't done any USB-C stuff yet. Is it pretty much throw down a chip and it kind of takes care of everything, or you need to call up Dr. Kaiser here and to get some signal integrity advice?
We're only doing it from a charging point of view. We're not doing it from a high-speed data point of view. We are doing like a serial interface, so we've got a USB chip on the primary side of the transformer that does some serial and outputs, and then we go over via regular serial UART optocouplers over to the secondary side. So it's really like low speed kind of stuff. Just for actually remote controlling the thing via the SCPI commands and stuff like that. So yeah, nothing fancy.
Yeah, Type-C is backwards compatible with USB 2 in a lot of ways.
Yep.
So if you just want to change to the new connector, there's not a whole lot that you have to do.
So Jeff, you've been excited about it too. You've been doing some of that higher speed stuff, the actual connections and things.
Yeah, I've been working a bit with Type-C, and it is interesting. Most of my experience previously had been at the lower speeds, but obviously things get a lot more complicated when you want to move data at gigabits a second. So if you really want to use USB-C and you want to go fast, it is definitely not trivial.
Yeah. It's not your first layout in KiCad or something like that.
Well, even from the charging aspect, it's very difficult. There's so many options and permutations of charging standards and things like that. It's a complete pain in the ass.
I think
really
USB is one of those standards that has evolved over time, and I think as time has gone by, it is sort of collected. Like a lot of stuff has come and kind of stuck onto it, and I think that it's one of the challenges that it's USB 2 is so ubiquitous that you have to sort of support all the legacy USB 2 stuff, and then you also want to support all the fancy USB 3 stuff, and then Type-C sort of adds another dimension. And I think one of the things that I think is a challenge for USB is that over time it's sort of gotten more and more complicated because they've added alternate modes and they've added all these different things to it.
I've got a good example of that, of where if you don't make the right choices, it can really limit your product or even kill your product potentially. One is the I forget the company's name, but the Chinese company who make the TS100 and the TS80 soldering iron, a little portable handheld thing.
TS80 is the USB-C version?
The TS80 is the USB-C one. And it's a really nice little iron. It's fantastic. But it only works with Quick Charge 3 compatible supplies. Oh. So the vast majority of people, your battery pack, everyone's got like a battery bank, right? One of those battery banks you carry it around. I guarantee 90% of them don't have Quick Charge 3, 95%. So it's like, that's automatically limited, and it's not compatible with anything else. Even at a lower power mode, it's like Quick Charge 3 or bust.
Yeah, I think
for that product,
that's one of the things. USB power delivery is a particularly complicated part of the standard, and they made some interesting choices in the voltage and power brackets. And like for example, there's a 5-volt rail, and then there's a 9-volt rail, and then there's a 15-volt rail. And if you look at...
And then there's a variable version, and there's where you can vary it.
Well, the thing that's odd is that desktop PCs forever, since the 80s, have had 5 volts and 12 volts. but 12 volts is not a rail that's available in power delivery. So they made some kind of weird choices in how they spec'd PD, and I suspect that if you cornered one of the USB guys and you got him to kind of spill the beans, there's probably a long story to how this came about.
Oh, I'm sure.
But what I've noticed is that some battery packs and some devices that support PD will support 12 volts, even though that's not part of the standard. Because you can, as long as you support the minimum, you can also support other voltages. And so that's where I think things start getting messy, because if 12 volts becomes common, then all of a sudden you'll see devices which are not spec compliant, which only work with 12 volts.
Yeah, it's an absolute quagmire of, various standards and options and
that is a lot
stuff
of options,
like that.
Huh?
It's crazy. But it jumps from 5 volts to 20 volts. It's like, Because I think a lot of that may have actually come from the requirement of laptop computers, because they're all around that 19.5, 20 volt mark, right? For
like
most
the standard
of
barrel
for the
jack
higher
connector
power
and stuff
type
like that.
ones. Yeah. Maybe that's where the history of that come from.
Yeah, I think one of the
perhaps.
holy grail of Type-C is that it supports charging of a laptop, and so I wouldn't be surprised if that was a factor. But even then, the waters are kind of
silly.
muddy there, because if you buy a Dell laptop and you buy a Dell dock, it charges at 130 watts, but USB Type-C only guarantees 100 watts, and so it feels like it's going to take some time for that to sort of work itself out. Like how when Bluetooth first came out, I think Bluetooth was around for probably almost a decade before it sort of became somewhat standardized. You could get high quality audio and stuff over Bluetooth. I suspect
but
that
is it destined to be just like the XKCD comic? Like, we have 13 standard, we have 12 standards, so let's make a standard, a new standard that standardizes everything. Bingo, we have 13.
Well, I guess we'll see. Yeah.
Well, what about standards on the RF side of things? I mean, are we seeing? What do you guys think about the state of RF communications these days? Like, there are more standards than ever. Are there any that are winning or losing, or things that you're interested in? I mean, that you're seeing on commercial products or personal products or anything like that?
Ooh, that's a complicated answer. I think that there's obviously things are moving to higher frequencies and higher bandwidths. There's some new 802.11 standards that are allowing for really large bandwidths. I think a lot of times there's a trade-off in range, though. So you have that kind of age-old problem with wireless routers, for example, where you can get great bandwidth if you're, 3 feet from the router, but if you move further away, you lose a lot of it. And I think that continues to be a challenge. There's work happening at higher frequencies now, like there's new bands that are, 60 gigahertz is a thing now.
Really? Wow.
But we haven't really seen much on the market. But that's the kind of thing where every year at CES, there's things at 60 gigs now. I think, who knows, maybe 2019 will be the year when 60 gigs finally starts getting traction. I think that'd be very interesting.
It's like an open band?
But they're not but just going to 60 gigs isn't some, magic bullet that's going to fix everything, right?
There's trade-offs, yeah. I mean, I think it's... The rules of physics cannot be changed, but we can find more and more creative ways to sort of work around them.
Yeah. I mean, what is the 60 gigahertz band? I actually have not heard anything about that, so.
I don't know off the top of my head. It's got a lot of bandwidth, though. The advantage... The advantage is that up there,
because no one's using it, and it's
not.
Because it's the window.
To be clear, you have two advantages. Number one is that you're the only transmitter, and then number two, it's that the channel capacity is huge because they allocate this large chunk of bandwidth. So what Shannon's law, like you have a lot more bandwidth to put information to send information through, and I think that's really that's the promise of 60 gigs is that you've got this large potential bandwidth that you can make use of. But 60 gigahertz is a high frequency for CMOS. Like CMOS is getting better and better, but I think silicon historically has struggled to get those kinds of frequencies, and I think that's something that's definitely the transistors that make up these RF circuits are getting faster and faster, and you don't need to buy exotic semiconductors like you used to. It used to be that you had to use gallium arsenide or indium phosphide to be able to produce. And automotive radar, I think, is in the 60 gigahertz band as well, and it's been around for quite a long time. Like Mercedes and other car makers have been building radars, but I think that back years ago they were using very expensive transceivers to do that. And I suspect that a lot of that stuff is in RF CMOS now on silicon and can be made much cheaper. Yeah. And that commoditization of like vehicle avoidance radar, and that's kind of gets back to self-driving cars too. That technology is becoming much more commoditized, and now it's actually hard to buy a car that doesn't have an automotive radar. And I think all of that stuff is pretty high frequency microwaves. I think there's some standard bands. I think 60 gigs is one. There might be some others, but tens of gigahertz and above kind of frequencies for that stuff. And so I'm not sure that there's technology from the automotive industry that's being leveraged for consumer, 60 gig Wi-Fi, but I wouldn't be surprised if those industries are sort of helping each other. And I think that is one of the big promises of moving to the higher frequencies is that you can sort of get around some of the bandwidth limitations of the existing 802.11 standards. And everyone's always trying to cut the cable and be able to have wired type performance over wireless networks. So maybe 2019 will be the year that we start to see more of that. I really don't know.
But is it going to improve the latency for shows like this? It's probably still going to suck ass,
we still have
right?
the speed of light going on. We still have that problem.
All right.
I mean, with your connection,
that's right.
Jeff's pretty close to the actual server.
Yeah, but it's all those pesky protocols that get in the way,
Yeah, I guess so.
Shuffling packets around,
Do you remember satellite internet? That used to be a thing, and there were it was like seconds of delay to get packets up to geosynchronous orbit and back again. I mean, that's a lot of miles away, and light can only travel so fast. Electromagnetic radiation can only travel so fast.
That's there actually was a link in our show notes this week. A friend, but I should be true to myself here. It's a friend I know who works there, but this new company called Hyper, and basically they're doing nano satellites for global coverage, and it's like high frequency band coverage for. So instead of like cellular communication, it's actually satellite communication for low power devices. So I was pretty interested in it. Right. I'm not exactly sure how it works yet.
So they're going to put thousands and thousands of little cubes up there,
and I think that's the same thing that I think SpaceX was talking about that too. It was basically just increasing coverage.
Right. Oh yeah, everyone's been talking
so that's
about
actually
it,
another Seattle. SpaceX has an office in Redmond, which is in the Seattle area. That's the office that's building the satellite internet network, and I think that's scheduled to launch in 2019. So
I don't get.
That's
exciting.
I don't
quite get how that works. Because doesn't that have the same problem that you're talking about? I mean, I know it's going to be like lower Earth orbit and stuff like that, but it's just a longer.
Well, when you're in lower Earth orbit, they're not geosynchronous orbit, so it's not directly above you. You have to catch a flying.
It's like a flyby
satellite over. Whereas if
that's right,
Whereas if you're geosynchronous orbit, where you've got the fixed thing, it's got to be much further out.
Yeah, so
it's got to be a long way out. That's why it takes so long.
A quick Google tells me that geosynchronous orbit is about 26,000 miles up, whereas low Earth orbit is just a couple hundred miles. So it's a huge difference.
Big difference. Okay. Yeah. And both have their pros and cons. The geosynchronous, yes, it's got continuous coverage always because it's just sitting on the one spot right above your head. Mm-hmm. But it's so far away that the latency is just insane.
That's right.
So
I think that's why the fleets of you need a fleet of satellites because a single satellite would only remain in your field of view in the sky for a very short amount of time.
Yeah,
like minutes. Yeah, exactly. Yeah. So you need a lot of them.
You have to know where they are, though, right?
Coverage.
Or would they just be beaming down?
Oh yeah. No, you would need to know where they are.
And then you've got to have the handover protocols and stuff like that.
Right.
So there's
so now it's like
all sorts of overhead
the cell phone
and
network is
like
going around you instead of you going through the cell phone network kind of thing.
Yeah.
That's it.
That's
interesting.
Right. That's right. And I think that's the problem that SpaceX, and I think Google had a project to do this as well. But the SpaceX project, I think, is based here in Seattle. And I mean, that's something that in 2019 could be pretty significant. If you can get high speed, and I actually don't know what kind of bandwidths they're targeting, but if you can get internet of any capability that's reasonably fast anywhere in the world, that's pretty significant.
I mean, then you start to get to do like the Star Trek communicator type stuff, you know?
That's right.
But the other thing is that who's going to buy it, right? It's all great to have this. Yes, every person on the planet can have access to it, but probably 80% of the world's population can't afford to buy it.
Especially the people in the most remote areas.
So it's,
probably,
it's one of those things.
Mm-hmm.
So
Dave's going to buy it for everyone. That's what he's saying.
Unless you want to give it to the world for free, then I mean, ultimately someone's got to pay.
I guess governments could. You say China pays for this.
Mm-hmm.
There's probably a good portion of China that does not have great high-speed internet. I suspect that's changing very fast.
Yeah.
Do they want them to have?
Well, they also could control the media, control the pathway as well.
So I mean, I think that's, and I think I've read an article to that extent a couple years ago that I think that is one of the challenges of these internet satellite clusters, is that if you go over a country that has specific regulations about what kind of content their citizens can access, like how do you even deal with that? Because a satellite can see users in multiple countries at one time, right? It's a couple hundred miles up. And I think that is one of the challenges. You fly over North Korea, and if you want to serve North Korea, you may need to have a different set of filters. So it's like you need to know where the user is located too, and then apply some kind of fence to their location. And I seem to remember reading a story. It might have been about the Google Project Loon or whatever a couple years ago that was sort of along those lines. But I think that is going to be a challenge for the SpaceX network and any satellite internet network.
Well, that could be a nice change, though. I mean, remote access is pretty cool.
Mm-hmm.
Okay, so Jeff says 2019 ubiquitous internet for all. Dave's gonna foot the bill. That's great. We're making good progress here, guys. You're welcome.
By the way, the band
humanity.
we're talking about there, the 60 gig band, is the V band for those. It's the IEEE V band, which is from 40 to 75 gig. For those
V for
playing along at home.
Very high
fast,
frequency. No, we already have very high frequency.
Right.
Very, very high frequency.
Voluminous data amounts.
Capital V.
Yeah, right.
Yeah.
So I was looking at the Gartner Hype Cycle for 2018 because we
what's that?
The Hype Cycle. It's that thing where they show where different technologies are on the.
Oh yes, that curve that has the little lump on it.
Yeah, exactly. Here, I'll share it with you guys. There's a bunch of crap on here.
Is that the one that includes the Valley of Death?
Yes, the Trough of Disillusionment, I believe. Yes, the Trough of Disillusionment. The peak of inflated expectations, the slope of enlightenment.
Oh, yes. Right. Augmented reality.
Yeah.
Augmented reality is currently in the trough of disillusionment. As of August 2018, augmented reality's there. It's the only one in the trough of disillusionment.
Yeah, so
I see Smart Dust over there. Smart Dust, I think, has been in that location on the graph for 20 years.
Definitely.
I think.
Yeah.
What recap Smart Dust for me?
I think it's extremely low power embedded systems that you can sort of just distribute. Like you think of your little spy network where you just blow particles into somewhere and you've got a bunch of autonomous sensors that are collecting data. I remember there was a bunch of work at Berkeley, I think, back in around 2000.
Energy, I'm sure.
I mean, how else are they going to get?
Yeah, exactly.
Yeah, they need to get energy somehow.
Right.
I'm excited.
Quantum computing.
I'm still excited about the
4D printing. Jesus, 3D printing hasn't even hit the bloody mainstream public yet.
What is 4D printing?
That's the one where it prints
I don't know.
and then you stick it in water and it unfolds and it makes a different shape.
Oh. I thought it was like 3D printing, but you have to wait a long time.
I mean, that's all 3D printing is like that.
That's already
right?
3D printing.
What the hell is neuromorphic hardware?
That would be like hardware that changes itself, I believe.
Right. Right. Human augmentation. A friend of mine's got a RFID thing in his hand.
Gross. Yeah.
So
body modders are weird, folks. I mean, everybody's free to do what they want with their body, but I can't look at it because my stomach gets queasy. So that's my only thing.
Right. He actually makes the news here a lot because he embedded the we've got a local card for travelling on the trains and buses and stuff, right? The Opal card. He actually took the RFID chip out of that and embedded it in his skin. And so he goes and scans his arm over the thing, and he's actually not been arrested by the police over it, but he's been questioned, like he's been fined
are you a
for
wizard?
not carrying his card with him. And he goes, but I do. It's embedded in my hand. And, so it's made the 6 o'clock news and,
Gross.
all that sort of stuff. So, yeah, there's a lot of things to overcome there. Controversial AI platform. This is great. We can make a whole nother show out of this.
We've done this before, Dave. If you don't remember, I know I completely gapped on having a guest on the show early on, but we've definitely talked about this before. There's a lot of crap on here.
Self-healing system technology. This is the way. This is
a
wank fest.
This is like basically a bunch of Gartner people charged about $500 an hour to go read research papers.
Yeah,
for things that could be implemented someday.
$2,000 an hour.
Come on. True.
Volumetric displays. What are volumetric displays?
I assume that's like holographic style things.
Yeah. Right. Yes.
Right.
Yep.
Deep neural network ASICs. Smart robots. What the hell's a smart robot?
It's a robot that goes to college.
Like a Roomba, but smarter.
So how about this? I had a Roomba and a 3D printer and a dishwasher going in my house the other day, and I did think for a second. I was like, feels kind of like the future, guys.
Yeah.
Robot vacuum, robot replicator. I don't have a replicator, but like it's George Jetson.
Very
I come.
Jetsons, you think? Meet George Jetson. What's a smart workspace?
I think that would be like. Do you remember? Oh, I guess there was a talk at HDDG about this, but who's the guy that does? Brett Victor. He does. He has a presentation about like contextual troubleshooting. It was actually a really cool idea. So John Barry, who is one of the particle folks, he did a talk about this, and he was trying to make, and I'll try and link that in. It was like a presentation about what if you actually made a smart workspace, and the idea would be like imagine holding like a screen. So say you basically we're sitting around So Jeff's troubleshooting a high speed interface, right? And basically you hold a screen over it, and that it basically picks up all of the information about it, and you have like contextual information around the device is, the IR signature is this.
So it's an augmented reality almost.
Kinda, right.
It's got to include augmented reality.
But also it has RFID.
So you mix augmented, right. So mix augmented reality with Minority Report.
Yeah, I think that's probably the easy. Yeah, Minority Report's probably the porn version of that, right?
Right. You've got the gloves with the projectors on them, and you just in your fingertips and you can project overlay on the board you're working on.
Yes, exactly right. Right. So so imagine imagine having an overlay for a PCB where you basically have the SPICE simulation and you can see all of the voltages as it's actually operating. That kind of idea. Like it is a very cool idea. It's probably overkill for what we need it for, but
and it's never going to happen in a general purpose setting. It has to be so specifically engineered that it's almost pointless for anyone else to use for anything else.
Well, it would be really good at raising money, if you were trying to raise money for a startup.
Oh, I'm sure, especially if you can include some crypto in it or something, and then it's
blockchain. Some blockchain.
Blockchain, sorry,
A little lost for that one.
Biochips, they just put in these generic wank terms. Like biochips is currently on the peak of inflated expectations.
Well, that's where it needs to be if you're gonna have wank terms.
And what's a digital twin? Is it like?
I think that's basically like you have.
We're in the technology sector. What's a digital twin?
I'm sure we could Google it, but my guess is you would have a online persona that matches your in-person persona, right? So you could transact in multiple worlds.
Does it include a social credit score as well?
Maybe.
I noticed that
this is just...
graphene is conspicuously missing, although carbon nanotube is on
graphene
here.
Graphene was the...
Yeah.
The carbon nanotubes are there, so maybe, you could lump them under the same banner almost,
Mm-hmm.
Yep. Yeah. Oh, poor Internet of Things platform is headed... Well, is that its new wank term now? It's not just Internet of Things, it's Internet of Things
platform. It can't stand on its
platform.
own. It has to have a platform, Dave. So.
Right. Virtual assistants, give me a break. That died with Microsoft Bob, with Microsoft Paperclip. That annoying paperclip. Silicon anode batteries. There's blockchain. There's blockchain.
No, blockchain's on the way down.
Fast.
Yeah.
Yeah. It's falling fast, but it'll pick up because it is the future.
I always get a kick out of seeing what technology CES seems to be centered around. Like every year, CES usually has sort of a thing. Like 3 years ago, I think it was drones. Drones. Every booth was a drone company. And I think 2 years ago it was like healthcare, like baby monitors and stuff like that. I think maybe 4 years ago it might have been connected home, like IoT. I think that IoT was probably about 4 years ago. So it'll be interesting to see what this year's theme is, because it's not necessarily that's going to be the next big thing, but that's what the industry thinks the next big thing is going to be.
That's it.
Are you going this year, Jeff?
That's
where
all
interesting.
That's where all the dumb investment money's going, right?
I will be...
Or the hopeful investment money.
I will be at CES this year, at least if all goes according to plan. Hopefully I will be able to make it there this year. I missed it last year, but it is a pretty fascinating.
I was there last year. It was
conference.
It was something. Definitely got.
And there we have connected home.
Where we're at, man.
Falling with a bullet.
Yeah,
it's there. I mean, I think we're there for a lot of stuff. It's just
it's so
it's
incredibly
still as pointless as
fragmented.
It was,
Well, I think connected home is a great concept. I think there's a lot of good stuff that's coming out of it, but there's still so much fragmentation. Like, which smart outlet you buy determines which app you need to use to control it.
I've done this as well. I bought into the Vera home automation system, right? Not for my home, but for another place. And it's like all it is like a motion sensor and a temperature sensor and a humidity.
Folks. One of you lucky listeners, Dave has snuck into your home and he put the Vera Smart Hub in there, and you are being listened to and watched right now by Dave Jones. Congratulations.
That's it. And it was one of the leading ones, yet it's its own ecosystem. Like you can't, lots of different manufacturers support the Vera standard. So you can buy all these sensors, and the system, like you can get in it through the web, but I can't even log the temperature. It's got all the, and I actually asked them, I went online and asked the Vera people, how can I, do something simple? Like, I've got my temperature sensor. How can I, you're one of the world's most advanced automated home systems, and so how do I get a graph of the temperature? And they go, you've got to install this graphene package. So I installed that, and that didn't work, and then it wouldn't automatically update. Then they had said, you have to write these scripts to then interface with the... And I'm going, geez, I just want...
I think the interoperability is
a simple log of temperature.
Honestly, that's on the software side, too. And that's...
Oh, yeah. But they're all different. Like, I had to choose, when I was looking at these systems, I had to choose which platform I'm going to invest in, right? So to speak,
Yep.
and then you're locked into that platform.
Definitely.
Yep.
So, and
I think that is absolutely...
There was no clear winner.
Yeah, I agree. It's still... I think that is the thing that is limiting... that and also the cost of every node in the network.
I think that's a big
seems
one.
like it's limiting. It still costs
They weren't cheap, they weren't cheap.
$30 or whatever to get a smart outlet, and I think it's you hit on one of them that is an annoyance of mine, which is that there isn't a great, the kind of data analysis tools that are available vary wildly by manufacturer, and I'd say they're all pretty terrible. There's not really one that's great. I've been meaning to go and try to find the open source project that does it right and try to figure out how to integrate that with the sensors that I've got. But I think that's you need a manufacturer that sort of is willing to invest in a standard and realizes that if they put everything out there, sort of what's the expression, like it'll elevate everyone if they can just make a common standard.
The rising tide lifts all boats. Is that what you mean?
That's exactly it. Yeah, the rising tide lifts all boats.
Then it comes back to the XKCD thing again.
Oh, the number of standards again.
Yet another standard to rule them all.
Yeah. Yeah.
I have no thoughts about
mixed reality. What is mixed reality?
It's
This is the second last one on the list. Mixed reality. Come on, Jeff. You work at a virtual reality previously augmented reality company.
I'm afraid you got me there. I don't know that one.
It's when you have augmented, reality. Virtual, and just reality. It's mixed reality.
They've got to. I want the full report of this Gartner thing where they actually
you really don't
explain
when you see
what
the
each
price
one
tag,
of them
Dave. You
is.
really don't. Yeah.
Oh,
maybe
right,
ask your viewers. Maybe one of them has one. They can slip it to you.
Yeah.
Well, Wikipedia says that mixed reality, sometimes referred to as hybrid reality, is the merging of real and virtual worlds to produce new environments and visualizations where physical and digital objects coexist and interact in real time.
Oh, sorry. I was too busy wanking there to give me a break.
I don't know how that's different than augmented reality though.
Speaking of which, was it? Did Jerry's technical illusions thing did that fold in 2018 or was it 2017?
I think 2017.
Oh, okay. Well, anyway, I don't think we've had you on since, Jeff. Have you got any commentary on that? Of what happened to augmented reality, Jerry's thing? And she's working on a new one. I don't know anything about it. I don't know if you do.
I don't either. No, I don't.
Right.
I don't.
So do you have any thoughts on the augmented reality versus virtual reality thing? But I guess you can't comment.
Touching a little too close to work there, Dave. Come on, man.
It's
possibly.
Yeah, I don't have sage wisdom. I'm not like a fountain of VR, an oracle. Yeah, an oracle of VR wisdom. I honestly don't know. I think both are interesting and very different, and I think it still feels like we're at the early stages. Augmented reality. I mean, HoloLens is out there, and I think there's some other AR platforms that have been out. It still
Magic
feels
Leap
like
came out finally.
There's.
That's right. Virtual reality's not on this list.
Yeah,
augmented reality.
Virtual reality was on the 2017 list in the.
So is that merged into mixed reality?
No.
Oh,
so
perhaps.
The 2017 chart had virtual reality on the slope of enlightenment. So I believe virtual reality is now the plateau of productivity.
There's nothing on the slope of enlightenment now.
Bad year,
And there's nothing on the plateau of productivity, so the whole industry's just ground to a halt. That was 2018.
I think past this thing, Dave,
it's just
I
nothing's
think past
productive.
this thing, there's actually people actually making money with companies. So, yeah.
Right. Well, they're way off the chart.
I kind of wish that each one of these little things was clickable. You know what I mean?
Yeah, I know. That'd be.
You probably have to pay for that version, the clickable one.
I'm sure you have to pay.
Maybe you can just put a little. You can choose to invest. Like there's a little text box near each one. You can put a number in. You get to invest. Accordingly.
Well, outside of this chart, Jeff, I mean, you had given. Actually, I just got this book back. I had lent it to someone, but you had told us 2 years ago about that Inside the Idea Factory book. Do you have any other books that you recommend? Since that one was a pretty big winner for me.
Since reading that book, I did read the HP Way. I read Bill and Dave,
that's a good one.
Which are the two books about HP. And I also read, there's a book that I think is long out of print, but it's the history of Tektronix. It's sort of like an autobiography of Tektronix. I thought that book was interesting. It's long. It has a lot of pictures though, and it shows early factory lines and they built CRTs in house, and I think back to vertical manufacturing. Tektronix was really they had the whole stack, and I think you can really see it in every piece of Tektronix equipment from that era. You can sort of see all the layers, everything from like back when they had those ceramic terminal strips that they did with this. They give you the silver solder that they included in the box or in the instrument. I think that the Tektronix book is, I think, an interesting read. Particularly, it touches a bit into the more technical details. I think one of the things that is often a disappointment for me when I read these kind of books is that the corporate histories, like, they don't really go into a lot of detail about the engineering and the kind of personal stories, because if you think about it, there's engineers that kind of created all this stuff. And if you think about, in your day-to-day life and the kind of challenges you solve, these guys were doing similar things back in the 50s, 60s, 70s. There isn't really a lot of that kind of history that's recorded. And when you think about it, some of the instruments that were produced by both HP and Tektronix in yesteryear, in the 60s, 70s, 80s, a lot of those are amazing pieces of engineering. And it's not like they don't still make that kind of stuff today, but I think that it may be a little more accessible. Test equipment was simpler back then. And when I open up a Tektronix oscilloscope from the 60s or 70s, you almost can kind of feel, for a moment, you can appreciate what the engineers that were designing that equipment, and not just the engineers, but the assembly technicians and the people that were doing manufacturing and all of the parts of the process. That's a thing that's not, at least to my eye, is not really captured in these corporate histories. I think the Tektronix book touches on that a bit. The HP way, and Bill and Dave, I was disappointed because I think the Idea Factory actually did a pretty good job of sort of making you aware of the specific technological advances and the engineering triumphs that occurred during the span of Bell Labs. And it sort of really gives you a sense of the kinds of engineering challenges that were overcome to make the first transistor and to build the vacuum tubes that used, electron optics and things like that. And it actually was it went pretty deep technically. The other books that I've got, you have to sort of fill in the blanks on your own. You sort of have to know, like Tektronix, if you talk about oscilloscopes, there's some scopes that everybody knows the numbers of that are sort of the iconic Tektronix scopes. And there's a history there. Like the evolution of oscilloscopes at Tektronix is a kind of a fascinating story. I don't know if anyone's ever done a really good job of telling that story. But, I think those, for me, and I'll be honest, I didn't read those books this year. I think last year I read the Tektronix book, and maybe a little bit before that on the HP.
Completely invalidated. I'm sorry, Jeff. You'll have to answer a new one.
Oh, sorry, guys. So it's only books that I've read this year.
Okay.
We're getting very very specific. Maybe my takeaway is don't read a book. Buy a Tektronix 465 and take it apart.
Yeah.
And that's kind of an interesting story just right there. Like they made their own CRTs. Like come on, that's incredible.
Yeah, that is crazy.
It's incredible.
Crazy. There was.
I've got a Tech 475 open on my bench here right now.
Nice.
Cool.
It's beautiful. You can just look at the craftsmanship in it. Like it just the assembly way everything's assembled and constructed. Yeah, as you said, you can almost visualize the people, actually making these things.
Yep.
It's like it's too sterile these days. Like there's this huge integrated, PCB assembled by machines. It's like, hasn't got the same earthly feel to it.
Or the smell of
old burning dust. Yeah.
Yep.
I had a book. This is the last thing I'll mention before I wrap up. At least I had a book that I meant to mention a while ago on here. It's called "Hot Air Rises and Heat Sinks. Everything You Know About Cooling Electronics Is Wrong."
I've got that.
You're the one who told me. You didn't tell me about that one. I think Colin. Colin O'Flynn told me about that one.
Yeah.
But
there's
fun.
actually a sequel. There's a sequel to that one too. I can't remember the title, but there's two books in that series.
Was it More Hot Air?
It might be like. Yeah, that's right. Yeah.
Yeah.
I have to get it.
Sounds
good.
It's a really interesting writing style. Maybe it was you, Jeff, who told me about it. It was either you or Colin, and I like it though. It's like this like very storytelling kind of method. I like it.
Yep.
So.
Yep.
And it's about a pretty boring topic too, you know.
One thing that I did recently, so MIT was one of the pioneers of radar. So in World War II, there was a laboratory at MIT called the MIT Rad Lab, and they worked. So the magnetron, of course, came from the United Kingdom. I don't know the history of the magnetron, but it came from the UK. It was brought over to the US, but MIT did a lot of the pioneering work on building radar, which is sort of one of the reasons why the Allies won World War II, was the availability of radar. Well, so after the war, you had this lab that was at MIT with a lot of brilliant scientists, you know, all the ones that were not at the Manhattan Project, right? They were building radar, and they stayed on for some additional time. And I think it might have been like 1948 by the time this was completed, but they wrote books. And those books are, of course, long out of print, but I think there's 28 volumes. Whoa. And they cover sort of every topic that you could imagine that you'd need to know to build radar. So everything from how to build cathode ray tubes to vacuum tube amplifiers to microwave transmitters and detectors. And, of course, all of this is 1940s technology. And I recently bought the entire set. I found somebody that was selling these books, and I was like, oh, this looks kind of cool. And those are the kind of books that are fun to have the physical book because you can leaf through them. And, of course, you know, they're from the 40s, and they've got, you know, beautiful quality printing and the covers and everything. But the neat thing is that they are all available as PDFs, so you don't have to buy the books, and I can send you a link to them. But the books are on all sorts of topics, and some of them are super interesting. Like there's a book about how to make mechanical computers. So how to build computers out of linkages and, you know, presumably for making bomb sites and things like that you'd need to make in conjunction with radar systems. And the illustrations are beautiful because they're all hand illustrated, of course. And so they're kind of a fun read. And so I've been sort of leafing through these, and I think there's probably some good project ideas that are lurking in these books. And there's a lot of material, like 28 volumes times however many pages. It's just it's a lot. So that's probably on my reading list for 2019 is to read all 28 volumes. I don't know, but to read a couple volumes of the MIT Rad Lab series.
Nice.
Sweet.
All right, guys. Well, it's been another good Kezyermas. Merry Kezyermas. Yes, sir.
Yes, sir.
Thank you very much for joining us, Jeff, yet again.
Yeah, thanks for having me back for the what number
5.
is it?
This is the fifth
time.
Fifth Kezyermas.
Lucky number 5. Well, yeah. Happy holidays.
We'll talk to you soon, Jeff.
All right. Thanks for having me on the show.
Catch you next time.
Okay. Bye-bye.